Cross-plotting. Cross-plotting allows interpretation across two volumes of attributes. I'll click the Add Probe button and create a probe to define the area of investigation. I'll take a moment to adjust the color and the line thickness so it stands out a bit better. I'll continue by clicking the pencil icon, which allows me to adjust the boundaries of the probe. Once they are correct, I'll click the pencil icon again to end the editing. Now that the probe is done, I can create the crossplot. I'll click on the Crossplot tab and click the Add button. I need to specify the volumes and the data type to use. In this case, I'm comparing acoustic impedance with VP/VS ratio. I'll click OK, and the crossplot has been generated. Now I am ready to view the crossplot. I'll click View, Crossplots, and select the new crossplot that I've just created. I can see here all the points that have been sampled from the probe that I defined. Relative frequency of the values is represented via the color bar on the left. I will load a statistics file that I prepared earlier. It contains a rock physics model defining regions of most likely probability across various seismic properties for several lithologies. After loading, I can assign appropriate colors to the lithology and fluid combinations. By referencing a specific depth in the rock physics model, I can see the regions of the crossplot that correspond to the properties predicted by the model. I'll select 3100 meters, which is approximately the depth of our probe. In this model, at this depth, I can see that shales are predicted to have a higher acoustic impedance and higher VP/VS ratio than gas sands, which have a lower acoustic impedance and lower VP/VS ratio. This indicates that we can easily distinguish between shales and gas sands for these conditions. Multiple depths can be explored, and you can see the predicted changes in rock properties as you progress deeper through the volume or shallower through the volume. Working from the rock physics model loaded in the crossplot, I can highlight the regions in the volume that correspond to each of the lithology fluid combinations. These regions are displayed in any view that intersects the probe that I defined at the beginning of this process. If I view the map window, I can see here the region of high probability gas intersected by the probe. This depth here. I can navigate through the depth and see the structure of that gas probability region. I can do the same for other lithologies also. If I switch to the Polygons tab, I can create planar regions and investigate where those values fall on the crossplot. For example, I've drawn a polygon here around this low impedance region. If I select this polygon in the crossplot here, all the points in that polygon will be highlighted on the display here. This low impedance region is closest to the gas ellipse, which indicates a high probability of it being a gas sand. I can further explore the data and the cross-plotted values by hand-picking a custom region. I'll start by defining a custom region on the crossplot and selecting its boundaries. I'll click this Add button here to create a new custom region. Click the pencil icon to start selecting points, and add these points into my custom polygon. I'll click the pencil button again to signify that I am finished editing. If I click the visible button, I can see all the areas on the main display that correspond to points falling within this polygon. These points may be an indication of other locations to follow up and explore or investigate further.